I kind of want to do one more song with the vibes, you guys, and then I see some more people possibly coming in here. So I'll allow a couple more people in, and then I'm going to get it rolling if that's okay.
It's great. Thanks.
Okay, that is like a 7-minute song. So, I didn't realize some of those instrumentals a little bit longer, and I looked up and I was like, wait a minute, we can't go through that whole song. But welcome everyone today to today's office hours. Quick power tips for computational design. This office hours is brought to you by Applied Software. My name is Misty Scott, and I'm pleased to be your moderator today. So let me get my cursor here. Here we go. As a reminder, you can find upcoming webinars, events, training on our calendar at asti.com/calendar. So just make sure that you check that out. I am super pleased to announce our speaker today. Donnell is a senior solution specialist with Applied Software. With over 10 years of experience in his field, Donnell specializes in Revit, computational design, and all things structural. So thank you so much, Donnell, for joining us today. And for you guys who are joining us, guys and gals, before we get started, I just want to say welcome to Office Hours. We've got some fun stuff planned for you to start us off. I hope you brought some snacks, maybe some coffee, but if you didn't, that's okay. We're going to hook you up. So for all who participate today with comments, questions, any type of participation, you'll be entered to win a coffee on us. And just depending on how fun y'all are, we might do a couple out there. So definitely make sure that you engage with us because we absolutely love it. All right. So to kick us off, I love trivia. So I thought it would be really cool to just bring in maybe an engineering field type trivia question. And this answer might surprise you. So how much did the world's first computer weigh? So you can answer this by coming off mute, throw something in the chat box, come on video, whatever you are comfortable with. But I'd love to hear y'all's guesses here.
2 tons.
How much do you think it weighs, Donnell? The
I'm gonna
first
guess
computer ever.
2 tons.
What? I mean, computers nowadays are like nothing. They're like lightweight.
Ounces.
Wow, 1,200. That is so exact. Did you Google that? 1,285 pounds. Okay. All right. Any other guessers here? Anybody else want to throw some stuff out there? Because so far, Andre's got the coffee. I'm just going to say. All right, well, I'm going to let y'all know because this is an interesting answer. 55 tons. And if you're not in the US, it's 50,000 kilograms. So crazy weight there. Just some fun stuff. And it came out of Pennsylvania, which is cool. So you were the closest. Yeah. So I guess you win. So yeah. No, it's pretty close. But 55 tons is crazy. Just insane. All right. One more question to get some interaction stirred with you guys today. Who in here is currently using computational design? So either you use it in the past, you're currently using it, or you maybe even you want to use it. Emerald Engineering in Tampa. Okay, so you're using it now. Okay, cool, cool, cool.
Awesome.
All right. Now, enough of my shenanigans. I will turn it over to you with the real stuff that everyone came here for. So I'll turn it over to you, Danelle.
Thanks, Misty. Great question. If you're currently using computational design, if you're not currently using computational design, this is a good introduction for you with computational design. So this is kind of our agenda today. So first, I'm talking about computational design, just give you a definition of it and what it means to us at Axton. And so we on like an even playing field. So when I mention the word computational design, you kind of know what I mean when I'm talking about. And then from there, I'm going to show you a tool demonstration, give you a tool, show you what it does. And then after I show you that demonstration, I'm going to talk about a return on investment. So I'm going to talk about kind of punching in the numbers and seeing, is it really worth to use computational design in your office? And if you're using it, then you can kind of use the same calculation to your own tools and see how much work, how much time you're saving, and or how much money you're saving your company. If you have it, it's also a good selling point to your higher ups to say, hey, we can save money and do great things with computational design. After that, we're going to go into a Q&A. Y'all can ask me anything, and we can have a good time. All right, so let's go right into it. Let's go right into it. So first thing, computational design, what does it mean? For us, computational design is a problem-solving methodology. Now, when someone talks about something like Dynamo or Rhino or PyRevit, these are all computational design technologies that we use to create computational design to solve our problems or to apply the computational design into. So that's kind of what I talk about. And that talks about the concept of involving these four basic steps: decomposition, pattern recognition, abstraction, and algorithms. All right. So from there, we're going to jump right into a demonstration. So this is a tool that we've created for a customer. And the object of the tool is that this customer or in your building, you'll have a whole bunch of rooms. And each of these rooms need to be take that room and need to be create a sheet for that. First creates a view. The view will be a plan view, and then a sonometric view for the customer. And instead of you going in and creating these items yourself by hand, we can get our computational design tool, in this case Dynamo, to do it for us. So here I'm going to go play this video for you. Let that go. So now I'm just kind of showing you the rooms. All right. There's about 30 rooms in this file right now. About 30. And I'm gonna show you some info on the room. So if we click on one of the rooms, you'll see that it kind of has the name, the number, and some stuff about the apartment. You see currently there's no views in our project browser, and there's no sheets. All right. So I'm gonna go access Dynamo. This is a quick mix of the graph. Pretty complicated, not horrible. There's more complicated ones, but pretty nice. So now I'm gonna run this. And then it's going to give you a little dialog box to ask you some questions. We're going to answer those for them. All right, and they have a little title block. You can pick any title block you want. That's one we're picking for this one. And then we go and run that. So we wait, and now you think about running it. This is about, I would say, it takes about 15 seconds to do this. That dialog box is out a little bit slower, which extends the time a little bit. But if you hit it pretty fast, you can probably get this in easily 15 seconds. All right. And then, so now we have that tool. We see nothing really changed in our plan. Now we go, you see that we have sheets, you see that now we have more views in the view, and you see all these sheets are created. So we go back to that last room that we saw on the list, and we look at that room, you'll see that now we have the sheet created with this plan on there. There's still some work to do with those. We still would need to kind of annotate those and do things, but this part of it set up. All right. So we'll go on to the next one. So now we're going to talking about our ROI. So if I was to do that same step just to do one room, it takes me about 5 minutes. That's 5 minutes for me to go to the room, create 2 sheets, create the view, the metric view, and the plan view, and then place them on a sheet, kind of exactly what we did there, right? This automation tool took about 15 seconds to do all 30 rooms. And then roughly the build time for that one script was about 40 hours, say, right? So I'm gonna do some more assumptions. There's 30 rooms per project, which is kind of light, but 30 rooms per project you need to do this on. And let's just say your company is doing about 100 of these type of projects a year, right? So when we start going in manually, I'm doing 30 rooms, 100 projects. They take me 5 minutes a piece. So that's about 15,000 minutes that it takes me to do this in 1 year to work for my company. And that comes out to about 250 hours. So that's how long I would spend if I didn't have an automation tool. To do this task, all right? So now with the automation tool, I'm doing 30 rooms. There's 100 projects. It's 15 seconds per room. So that comes out to, and for the whole year, I'm spending about 25 minutes or less than a half an hour to do the same exact task, right? So now let's talk about the money, right? The money total savings is, in terms of hours, we're saving about 209.5 hours a year. It goes up because the first year we actually spent some time to make it. So that's how we get to 250 is the hours that it would take us to actually do it by hand. 40 hours is to make the tool, and then a half an hour of us actually just running the tool instead of doing it by hand. So that comes out to about 209.5 hours a year that we'll be spending for this. Now, next year will be different. It would be 249.5 hours to actually do the same task, right? And then that comes out to, and I'm doing the estimate about $145 an hour. Could be more, could be less, depending on your company. But then that comes out to be about 30,000 a year, a little bit more than 30,000 a year that you saved on just the first year using the tool. Now, if you use it another year, then that's 36,000 you'd be saving a year. And this is kind of a good example of how you can use. You can have one tool can really make a big difference in your firm, because this is just only one tool doing one task in your projects. There's many other tasks you can do. There's many other tools you can make. And you can really save your firm a lot of money by using computational design. All right, there's my little spiel for you. What questions do you have for me? It's all open. Taking down my my presentation. I would say I kind of put it in the bucket. So Andre's making a question about making views and sheets per room. Would that still be within the realm of computational design and process automation? And I say it was, it's kind of both to me. You could say process automation, but I put computational design as a really big bucket to envelope all that stuff. Computational design is a really big bucket talking about, using programming or this programming method to help solve problems and do things. So process automation is one of those things you can do by using by using computational design to do that. Does that answer your question, Andre? Yeah, great question. Yeah. Yeah, so we always like to think of computational design as a really big bucket, of a lot of things that you can do with it, and it's outside of any technology, and you can use it and define it in many different ways to kind of help your company do things. Don't discredit talent retention. Teams are happier when they don't have to do tedious work manually. That is also a heavy savings for the company. Yes, that's very true. You know, The way how I got into computational design was because someone introduced computational design to me, or Dynamo to me at that time. Computational design, the word wasn't really buzzing, but Dynamo was coming out. And they explained that to me and told me what I can do with it. And then as I was working, there's always these tasks that I didn't like to do. I like to do, and my background, was in structural engineering and architecture. Structural engineer, I was a structural engineer when Dynamo came out. And I really like designing buildings and making floor plans and doing things like that, but I didn't like to copy information from my analysis tool to my Revit all the time. So these computational design tools really help that and really make you happier at work because you're doing the things you love to do, and the things that you don't really like to do, the tedious stuff, you kind of push the computer to do that. And not only do they do it for you, but they also do it faster than you could do it by yourself. Thanks a lot for your comments and questions. Is there any other questions?
Yeah, I think Andre is on a roll. I mean, just loving it. You must love Starbucks coffee like me. Can I tell you, when I go there, I don't even have to order it. They know my name and my son, and they know our orders, and it's terrible. I'm so embarrassed every time, but I'm also like, yeah, yeah. I'm here every day. Coffee and computation. You know what? It's a C and a C. It works. Coffee and computational design. I didn't even see that. You've been in computational design since 2012. 10
Very
years.
nice.
Yeah. All right, man. All right, guys. So just want to allow, if you've got any other itching questions, comments, please come off mute or put them in the chat box. We do have, go ahead.
Oh, sorry. I was gonna just ask Andre, what technologies are you using in your firm for computational design? Dynamo VBA. Ah, nice. Yeah, I learned VBA too because it connected well with RAM structural systems, and I learned VBA to do some stuff with there. But Dynamo, yeah, was my first start at computational design programming. Nice. Yeah, if you could do VBA, you can do just about. I say if you could do one programming language, you could do them all. You just probably just need some help with the syntax. I haven't had EuroCAD actually. Oh, you probably meant AutoCAD. Sorry. Yeah. Oh yes, yeah. I remember list routines. I did a couple of those. Fun stuff. It was always this new breaking thing. It took me so long to make my very first one when I did list routines, but it was kind of fun. In my first VBA, when you get to use the like follow like I forget what it's called now, when it just does everything that you just do, so it records what you're doing, and then you can just use that, adjust the code, and you have your first script. That was always fun. Recording macros. Yeah, there we go. Thanks for giving me the term. I haven't used VBA in a good bit. Yeah. So we have plenty of time. So anyone has any questions on computational design or how to move forward with it, we have more than happy to answer any questions. You know, my background is I was in a firm before coming to ASHD, and we did kind of go that journey of creating tools, and I created tools for my firm that they use, and they really enjoy it. Since learning Dynamo, the first thing I learned was Dynamo. And after learning Dynamo, I wanted to get a little bit more control and do some stuff with the Revit API. So then I learned Python. And then the next step after that, I was like, I want to do some more and make my own add-ins for Revit. And I learned C#. All these things that kind of help us manipulate and work a little bit better within Revit. Can you give us you want to know like a script that I created for structured design? Or what exactly you mean? The question is, can you give us a prideful example of one of your structural computation design programs? Um, just like a script. So I think so in my firm that I was working at the time, we um, um, it was I would say it was a set. I was in charge of building out our tool set, and I would say that each individual tool wasn't spectacular, but I think as a whole it was great. So different tasks that we had to do. So like seat setup, we had to like change some lists. So I think the script to me it was like really diving into my first time really diving into Revit API, and I learned all about schedules, and I learned how we can edit our schedules programmatically to kind of speed up that process. So everyone talks about it takes hours to go in, and we have to change our schedules to update our notes for our project. So I created this script that kind of goes in and cleans out the notes for you automatically. That was probably one of the more ones that I would say it's probably not my most advanced script, but at the time it was like my first real script that I did that really worked out really well. Everyone really enjoyed it. So that's probably one of my proud moments. I think I'm more interested in the scripts that everyone can use than the one that's the fancy programming and kind of doing things. Also, the room data sheet was a very good one that I really like to do. So yeah, that whole suite, we did a couple things like placing families in it. So it did quite a few tasks in there. Um, Exporting sheets for views. So all great stuff. Yeah, thanks. What kind of stuff are you working on or I have done for your company, Andre? Do you mind sharing? There's a command in on the API for rotate. You can just rotate it by transform. Um, Let me get open. Let me share my screen and I can kind of I will have to pull out the script to tell you. Let's see if I have it open. I'll pull out the script. The script was done a little bit ago, but I'll pull out the script so we can look at it. But I am pretty sure I can show you the Revit API. Let me share my screen. Here. So when I manipulate the Revit API, I go to this website called Revit API Docs, and this kind of gives you the API. And I'm pretty sure there's a rotate in here. Yeah, there's a rotate method, right? So, oops, rotate method right here.
And Andre said, I can rotate, but not from a specific point. Code place receptacles.
Let me see how I did it. I know I actually have one. So one that I did was, let me see if I can open up Revit. Let me see how I did it. Okay, this one. I'll go to one of my old scripts. Let's see how I did it. Because I know it started from a point to rotate an object. I might start from the center location, but let me check. Let's see. Because couldn't you make a line from that point? So if you're talking about you want to put it on a certain point, you'll just make a line from that point. So what I would do in this, like just looking at this, is what I would do is, let's see. Let me see if I can get a little marker, right? So let's say I have this oops, I'm starting from the annotation. So let's say I have this square right here, right? And I want to rotate the square, and I want to rotate it not from the center, but I want to rotate it from the corner, right? So I can in Revit API, you can go in and get the geometry and kind of get this point for this corner. And then from this point in this corner, I can take this point and then just do a transform so that I get another point, 2 feet north of it, right? So now I have, this is my line. And then now I just make an angle and I can rotate it around that point. It's just asking for a line anywhere. But I'm gonna see how I did it in my previous work. I'm just waiting for everything to load. But that's just looking at it like right now, saying this is the rotate method. You need a line of axis, which is going to be this one that you make. So you make from these 2 points. So X and Y that you can get from this geometry of this object, right? And then the function is, this is just a double. So it's just a number of the angle that it rotates, right? So you just give it that number. You can rotate from that individual angle right there. But let me see how I did it in my Python script. Hold on a second. So yeah, I had this really simple, so I was doing a program, and this was the quick version, I would say, of it, I could get it to automatically rotate. So let's see. Yeah, so that's what I did. I took the location center point here. So this is I have this object that the person selected. So this is getting an object from the selection, all right? And then I'm getting from that object, I'm getting the location point, and then I'm just getting the endpoint is just this start point here, plus the y of that start point with just adding 1 point to the z, so just one unit above from where that is, and that creates my axis, and then I just give it then I create that line, so just creating the line, and then from there I'm just creating the rotation based on that. All right, and this negative pi over 2 is just a 90 degree. All right, does that answer your question? Maybe this is actually probably making it hard to see what I'm doing. All right, yeah, that makes it a little bit easier. So, we're taking that object, pulling out the location point, and then from there, I'm using that location point to create the location where that is, and then that'll make my axis for me, and then I'm using that axis with a degree to rotate it.
Andre said, does that work with groups as well?
Yes, because when you get a group, you can get the center point of that whole group. All right, so you can get a center point of that whole group or from a certain object. I think the hardest part for what you're doing is trying to find where you want that point to be. And then once you get that point, you can take that point and make another point based on some parameters from it. And then that's your axis, and then you can rotate it. But it should work for groups. Because what I'm doing here, this is just getting selection and just taking the very first item from the selection and using that one as your point. But you can put as much logic as you want in there. Yeah. Great question.
All right.
Yeah, that's a really good question.
Yeah. Fantastic. And it looks like we have reached the top of the hour here, or half of the hour, however you want to say it, the mid part of it. So I just want to thank everyone who has joined today. We do hope that it was impactful for you and your business, and we do look forward to seeing you on future webinars and office hours. So thank you all. Have a wonderful day.
All right. Thank you, everyone. Have a good one. Bye.